Hello everyone, our group topic is experimental study on microservice orchestration with Amazon Step Function. Here are four team members, Huaxin, Siyang, Chen, and Iran. And let's get started. First, we address the comments from panel review 1. The problem statement part was ended too abruptly, so we add a summary to the problem statement. There are also some typos. We fixed the typos. The innovation part was more detailed explained. The motivation of this project. So what is a step function? Step function is a serverless orchestration service that allows developers to create and manage multi-step application workflow. The benefit of the step function is that it offers drag and drop visual editors. Team can easily assemble individual microservices into unified workflows. But the problem with the step function is that there's not enough study about how step function compare with code-based orchestration and event-driven application in terms of the cost and performance. Problem overview. Our approach to solve this problem is to build our own application using four different approaches: event-driven application, code-based application, and step functions. Here is a typical e-commerce application example. People place order from Amazon, Amazon validates the order, and then charge the customer, and then delivers the package. How should I build this system in event-driven architecture using low-level AWS services? I start with the entry point, and I use a Lambda function to validate the order, and then save the result into the DynamoDB, broadcast to the next stage using SNS. Next, I'll have a Lambda function again to charge the customer and broadcast to the next stage. The final stage, I'll have a delivery package Lambda function and save the final result into the DynamoDB if the order is complete. This is the JSON payload we will be using as our input into the workflow. There are four objects into this big object. There are orders, customer, payment, and the delivery details, and we will be updating those details while we work through this workflow. Next is a quick demo. Here are my Lambda functions: validate order, charge customer, deliver package. Here's my DynamoDB tables, SNS topics, and CloudWatch trying to monitor what's going on. I'll not have a code work line by line into this code, but rather have a quick demo here. If we hit test, this is the payload JSON that I introduced before. And if we hit test, as you can see, the execution is successful. And then if we go to the CloudWatch, I'm trying to refresh that. And let's see, going to here, we got the new result here. This one showing what's going on. Here are more results from the AWS CloudWatch. I have shown you this one before, but here's a result from other Lambda functions. What are the advantages and disadvantages of using event-driven architecture? The advantage is that there's no orchestrator involved in this application, so it is very easy to implement. It is fast, low cost by only using the AWS low-level services. The disadvantage is that the monitor each step is complicated. We have to use AWS CloudWatch or database record, and it is also very hard to handle the errors. This is a parameter I'll be using to compare with the other three approach, the runtime and the cost. This is a table I'll be using. Later I'll fill up this table and draw a diagram to reflect the result. Thank you.
So my implementation is on Express workflow. Let's focus on the architecture first. As you can see, there are three major components: the order value, and the charge and the shipment parts. After the order is made and it passes our validation check, it will send the user a notification on its creation results. Then we go to the charge part. It also needs to do some basic check and save the charge result in bill history table, and also notify the user the payment result. Then it go to the shipment step, save the shipment order in database, wait for the shipment to complete, and notify the shipment results. And the next step, let's do a quick demo of running this workflow. As you can see, our input is a JSON file with the specific details about this order. And let's start execution. One convenient thing about this express step function is that we can directly see the progress of workflow. If it fails, we can directly see at which step it fails, and we can also monitor the input output of each step. And let's go back to the slides. And the next thing that I will introduce the feature about this express workflow is suitable for high volume event processing workloads, and it supports high volume execution start rates, nearly unlimited state transitions, and unlimited execution history. It's limited to 5 minutes maximum duration. It's worth noting that we limit our Lambda function execution time to 5 minutes maximum to make the experiments comparable, especially with express workflow and the standard workflow. For the building part, it's built for the number of executions, duration, and the memory consumed. It's also affected by the Lambda cold start, warm start stage. And for the parameters, I'm focused on the execution time, state transition time, and the number of states. Below is the Excel form that I make for one single executions, and the parameters I collect from the CloudWatch, X-ray, and the set functions panel. One thing to note is the number of states is left to be play around, since I may combine some states together to change the number of states to see how the test results. And for the future step, I will run more executions to collect more data for statistical meaning, and I will draw diagram to visualize and compare those results. Another thing is that I will analyze and explain the reason for the performance cost difference between different workflows, and maybe I will bring up some improvement ideas. And that's all. Thank you.
Hello everyone, so this is Chen Chiu speaking. So now I'm going to start my part of standard workflow step function. So let's talk about feature first. Standard workflows are ideal for learning and viewable, but it's for only limited execution start rate and state transfer rate. Also, it employs exactly once more, which means most your tests and states can never execute more than once. Therefore, it's really multiplied by the number of state transitions. So talking about my implementation, I'm going to use step function standard workflow to build like order services. I will use an initial. I will use a JSON object as an initial input. So this data will be passed to step by step and to process it, and in the end we will know whether the whether or not the order service is sent or failed. So let's look at the architecture diagram. So basically, the application are mostly are built with Lambda, SNF, and DB. So it contains many three modules: the order validation and chart, and then it's delivered. And so now let's take a look at how this step function really works. So let's start a new execution. So we can see as an initial output, we contains information of data, customer, payment, and delivery details. So let's start execution. So for this data, it will be passed from the start point to validate, and then if it's the safe, then we'll charge customer and start shipping, and then finally success, which means the order is completed and delivered delivery. So let's back to the slide. So for the parameter, we are going to explore the major part is the workflow, because we are going to compare the cost and performance for each applications. For step functions, the three major parameters are state transition duration, number of state, and execution duration. So let's take so in the next slide, in the next slide, this is this version I used to store the start time, end time for each state, for each state. So we can see like we can see clearly also the number, the duration of each state, and how long it would cost to transition to another state, and how many states are there for each part.
Al Imran. So since we are comparing AWS step functions to different implementation, I will explain our API gateway architecture to you. So in this implementation, we will have a microservice. We will call it the API gateway. So this API gateway will take a request from the clients, and it will then send requests to appropriate services, take their response, analyze the response, and send the final response back to the client. So in our case, in our demo application, we have several lambdas. The first one is validate order. So this lambda will retrieve the product information, check inventory, check stock, and if everything is okay, it will then return a response. The second lambda we have is charge customer. So this lambda will charge the customer. And the third lambda we have is called delivery package or shipment lambda. So this lambda will process the order and prepare the order for the shipment. So this is the diagram of our API gateway architecture in terms of our demo application. As you can see, all the requests from the client is going through the API gateway, and this API gateway will work as an orchestrator. So in step functions, AWS state machines works as an orchestrator. In our case, the API gateway will work as an orchestrator. As you can see, this API gateway will communicate to multiple services to process the request, and then it will send the response back to the user. So this API gateway architecture has several advantages and disadvantages compared to AWS step functions. So as for advantages, the first one is we are avoiding vendor locking. So since step function is a feature offered by AWS, this step function or workflow orchestration, this service is specific to AWS. So since we are not using any specific service from AWS, we are avoiding vendor locking. We are also not limited by any memory or time restriction that we usually are by the AWS. We will also avoiding the extra billing system from AWS. So we don't have to worry about any extra billing. So since we are not using AWS step functions, there are also some drawbacks for this architecture. So the first one is the single point of failure. So since all the requests will go through this microservice or this API gateway, so this API gateway, if this API gateway is down or crashes for some reason, all the requests will be declined. It will also add an additional complexity because this API gateway has to be maintained, developed, and deployed and managed by the developers. This will also have this API gateway also has tight coupling with the lambda. So if there is any update to any of the microservices or lambdas, this API gateway has to be updated as well. So this is it for the API gateway architecture.